Okay, this is going to be a quick video on inverse trig derivatives. In class, we should have worked out the derivative of arc sine of x. It's 1 over root 1 minus x squared. That's just a formula we have to, unfortunately, memorize, unless you want to work it out every time. But we can limit ourselves to just arc sine and arc tan and be mostly okay. I'm going to show you two arc sine derivative examples, and then I'm going to show you what the derivative of arc tan is. So this is our formula, and from here we just do a derivative the way we would normally do it. I would like you to think about what the derivative with respect to x of sine of 8x would be. It's a quick chain rule problem. You would do the derivative of the innards, which is 8, times the derivative of the outer, which, the outer is sine of. The derivative of sine of is cosine of. And then what goes in the of? My original 8x. So that's just chain rule. This arctan, or the arcsine here, is sometimes a little funky dealing with the chain rule for people. But if you can think of what's going on here, then you should be able to do this one. So what we can think about is that arcsine of is 1 over the square root of 1 minus of squared. So here our of is the 3x. So we'll use that 3x in a moment, but first thing I want to do is take care of the equivalent to this. When I derive sine beta x, I need to do the derivative of the innards out front. Here the innards is 3x, so its derivative is 3. And then I'm going to multiply it by 1 over the square root of 1 minus of squared. What goes in the of? My original 3x from right here. So I'm going to write 3x. So you should simplify this. The 3 here is going to go up top. So I'm going to get 3 over square root of 1 minus. Now this 3x squared is 3x times 3x. When I multiply that, I get 9x squared. So that's our answer for that one. And it should, I hope you see it. So the next one I want to do is the derivative with respect to x. Come on. The derivative with respect to x of arcsine of x cubed. So why don't you pause and see if you can do it on your own, and then come back and we'll do it together. Okay, I'm going to go ahead and do it. The derivative of the innards is 3x squared, so I'm going to get 3x squared, times the derivative of the outer is 1 over root 1 minus squared. What goes in there? X cubed. So when I simplify this, I get 3x squared in the top. In the bottom, I get a square root of 1 minus. Now, get out of here. The x cubed, some people mess this up and write x to the 5th. It's x to the 6th because it is x cubed times x cubed. How many are being multiplied in that? I'm simplifying this piece right here. I get x to the 6 because there are 6 of them being multiplied. Okay, so hopefully you see how to take the derivative of an arcsine of something. There's one other inverse trig function I've already said in this video that we need to know, and that's arctan. So I'm going to work out the derivative, but I won't do any examples. If you're able to be in class today, then you saw me work it out for arcsine. It's pretty much the same process. So what we do is we start with y equals, actually I don't like that pen, y equals arctan of x. And I want to find dy over dx. That equals what? Now you might remember how we did it with arcsine, and if you'd like to try to do the same thing right now and try to figure out what the derivative is, you can go ahead. And you know what I'll do? I will actually tell you what it is, and we'll see if you can get there. So the answer to this question is that the derivative with respect to x of this thing, so I'll write dx of arctan x is equal to 1 over 1 plus x squared. So if you would like to try to do it yourself and then watch the video at fast speed or something like that afterwards, that's fine. If you're like, nah, I'll just let you do it, then you can come along here. So how do we get this right here? So I'm going to answer right now. Why do we know that that's true? Well, we do the same thing we did with arcsine. I'm going to take the tan of both sides. That gives me tan of y equals tan of arctan of x. What happens here? Well, I'm left with tan of y on the left side. The tan of the arctan cancels and gives me x. This we did in class before. Take the derivative with respect to x. I get dy over dx equals, times, derivative of tangent is secant squared x, y, because the input here for the tan is y. And then the derivative of x is just 1. From there, I divide by secant squared, dy, over dx is equal to 1 over secant squared of x. Now, this is one for which it's good to switch it. So you should know that secant is 1 over cosine. Therefore, 1 over secant is going to give me 1 over cosine. 1 over secant squared, what we have right here, is going to give me just a cosine. Come on, little pen. Squared of x. So, we're going to do the same thing we did last time. I'm going to take this, turn it into a triangle, and use it to calculate what cosine squared would be. So, I got tan of y is x. I'm going to write that as x over 1. Tangent is opposite over adjacent. So, I'm going to draw a right triangle. I'm going to make y my angle. I'm going to make my opposite side, because of this right here, I'm going to make my opposite side x. I'm going to make the adjacent side 1, and that's adjacent and opposite to the y. So leave my right angle. From here, we're going to use Pythagorean theorem. Well, if I do a squared plus b squared is c squared, I get x squared, if I call this c, plus 1 squared is equal to c squared. So if I solve for c, I get c equals the square root of, and I'm actually going to write it as 1 plus x squared. So we can erase this and write square root of 1 plus x squared. So from here, notice I got a cosine squared. That's my goal. I want to figure out what cosine squared is using all this purple triangle stuff over here. So I can find cosine first. Cosine of y. Ooh, I got an error here. Maybe you caught it. Y. Sorry about that. Hopefully you caught that and you saw it. But remember, I got the cosine of y because y is my angle here. So, cosine of y is equal to adjacent, which is 1, over hypotenuse. So I get 1 over the square root of 1 plus x squared. Notice here I want to find cosine squared of y. So cosine squared of y is equal to this thing squared. What happens here? The 1 gets squared. It stays a 1. So cosine squared of y. The 1 stays a 1. And then the square here cancels with the square root and gives me 1 plus x squared. So this is 1 over 1 plus x squared. And it feels like, okay, but that's it. We're done. I've now proved that the derivative of arctan is 1 over 1 plus x squared. This thing right here. And chain rule and stuff like that works the same way as it did with all this stuff here. So if you understood this, you should be able to apply that and do some chain rule with this. Next thing we're going to do with all this is learn how to use these two formulas to do some integrals. And that is the real power of these things. And we'll do that in our next class. Thank you. See ya.